right, today we begin our last lesson, really, of new content for the year. Wish we had time to be together and do a ton more, but I guess we just will get this far. So, today, starting with this little cute picture here, I saw it the other day, although I've seen it many times, and I really like it. How to be a math person. Step 1, do math. Any type. To be a person. So today we get to be math people together, and we're going to talk about circles and their area and circumference, and then a fraction of each of those, which is arc length and sector area. So let's go through this together. Just to kind of review, last time we talked about degrees and radians, and we talked about how to convert between the two. So just make sure that you're comfortable with that. Other than that, we need to just recall really quickly what we know about circumference. So I'm going to put that here. Remember that circumference relates to the distance around a circle. So when we talk about finding the circumference, that's like finding the perimeter of a polygon, right? This is the distance around the circle. So if I were to take a string and measure this circle all the way around, that would be its circumference. So we're talking a distance and a length around. And actually the equation for circumference, right, comes from understanding the relationship from the diameter. Diameter, remember, is a chord that goes through the center. So if we were to take a little string again and measure the diameter here, and then we were to take that diameter and we were to wrap it around, this diameter would go around a little more than 3 times. It would actually go around pi times. So when we find the circumference, an equation for that is just the diameter, right, times pi. So we can find the circumference of the distance around a circle. The other one, the other way that you generally see it written is 2 pi r. I don't know why we always put the r at the end. But 2 pi r is the same thing as diameter times pi, right? This example, r is just the radius. And so we do 2 pi r because we have to double that radius so that it's the same length as that diameter. Okay, so you can use either of those. The next one that we just need to recall is area. So if we want to find area, this one instead is the whole space occupied by the circle. And it's important to realize, right, this one's in square units. So when we talk about finding the area, this is where we're talking centimeters squared or square inches. And this one you're talking about the whole space occupied by the circle. So you're finding all of this space inside of there, the area that's covered by the circle. And our formula for that is related specifically to the radius of the circle. So this is pi and then r squared. Okay. Again, the area, you need the radius. The circumference, you can use the diameter there. And then lastly, the thing that we just need to remember is that we're going to talk about different sections of the circle. So if we're looking at something like this, we can talk about arc length, meaning we're talking about, right, the arc here. Now, the difference we talked about before, an arc measure. An arc measure is just the degree of rotation. Okay, and I'm just going to write this out just so we kind of distinguish between the two. So this is like the degree of rotation. So if I were to tell you that that was an arc measure of, say, 50 degrees, ooh, that kind of looks like a 50, 50 degrees, then we know that this arc was created with a 50-degree rotation at that center. Now, today, as we calculate arc length, okay, this is actually the length, okay, that seems redundant. The length or distance, right, covered by the arc. So this is not just a degree measure of rotation. This is actually, if we were to take out our ruler and we could measure that arc, how long would it be? Okay. So today our central angles, they'll be given in either degrees, or you may see it given in radians. So it may be that you're looking at another angle, and if we were looking at this angle right here, and we were saying, okay, well, that's the same thing as 2 pi over 3. then you would be using your radian measure. And if you're more comfortable with degrees, you can convert that to degrees and then calculate in degrees. But I'll show you that radian measure is just as simple to use. So let's jump down, find arc length and sector area. Again, this one's just a matter of using the formulas today. You're just going to practice with the formulas. So first of all, the arc length. Again, the arc length is just a fraction of the circumference. Okay, that's an S, circumference. So we're talking distance around the outside. So if I'm looking at this piece and I'm given something that looks like this, right, and I want to find this arc length right here, then I need to use the radius measure. So whatever this radius is, let's call this 3 centimeters. And let's say that we're looking at an angle here of 40 degrees. Okay, so you have a circle with a size 3 centimeter radius, and you're rotating that 40 degrees. So then you're asking yourself, okay, well, what length am I going to end up with if that's the case? Okay, and the way that we do that is we say, okay, well, if we were to find the whole circumference, all I'm going to do is take a fraction of that circumference. So when you calculate arc length, if it's in degrees, right, all we're going to do is we're going to say, well, the whole circumference would be like 2 pi r, or you can use diameter times pi, and then you're just going to multiply it by whatever fraction of the circumference that you're trying to find. So in this case, right, you're taking whatever that theta is, that central angle, and you're dividing it by 360, because that gives you the fraction of the circle. So we would say, well, 2 pi r, in this case our radius is 3 centimeters, and we're only going to find 40 out of the 360 parts of that circumference, okay? And then it's just a matter of multiplying that together. So for today, you guys are just going to be approximating. So in this case, you would just put that whole thing in your calculator. You could just do 2 times pi, multiply that by 3, right? And then times it by that fraction, 40 over 360. And then you should come out with, in this case, it looks like it's about 2.1 centimeters. And we're just talking about length. So we're just looking at the length of that would be about 2.1 centimeters. Okay. And that is our formula right there if we are in degrees. So if your angle is in degrees, you're just going to calculate that arc length there. Now I want you to notice sector area is very similar, but area in this case, this is a fraction of the area. So if I'm finding, again, I'm going to use this same example that I did on the left. So if this is 3 centimeters and I want to find this sector area with an angle of 40 degrees, instead of just finding that arc length, we're finding, well, what would the area of this slice be? Okay, so again, I'm finding a fraction of the area. So this works very similar if I want to find sector area and it's in degrees. I'm going to take pi r squared because that's the area formula, and I'm going to multiply that by, again, the fraction of the circle whose area I want to find. So in this case, again, I would say, well, the sector area is equal to pi r squared. The radius is 3, and make sure again that you're using the radius there. And then again, we'd multiply that by the 40 over 360. So we're just calculating that there. So again, you're just going to put that into your calculator. And once you put that into your calculator, you'll just be rounding your answer there. And let me plug that in really quick. 9 times pi times 40 divided by 360. Oh, and it looks like actually this is equal to pi, or about 3.1. And again, these are squared units, so we're going to say squared centimeters. Oh man, I miss having you guys calculate that and checking my work. So hopefully we're good there. Let's talk about radians then. So again, let me box this. This is our formula again for sector area. Again, if it's in degrees, pretty straightforward. Just find the area and then multiply it by the fraction. Now, if it's in radians, so let's say we're looking at this guy down here. And again, this is, let's just call this 5 centimeters. And if we're looking at an angle here, let's call this 100. Oh, but we're going to do, let's do 2 pi thirds. So we're looking at that one. So let's say this angle instead is given to us in radians. And again, we can tell that's radians, right? It's got that pi in there. In this case, we talked about the radian measure is related directly to this radius length. So basically we're saying how many radiuses around this outside would it take for us to end up with 2 pi thirds of them, right? So when we're doing arc length and it's in radians, then we actually just take whatever the radius length is and we times it by the angle measure. So whatever our angle is, we're going to multiply that by the radius. So in this case, we're going to take 2 pi thirds and we're going to multiply that by 5. Okay, and it's that simple because those are directly related. So that would be the same thing as like 10 pi over 3, or again, if we wanted to multiply this out and approximate it, then we would multiply 10 times pi, and then we would divide that by 3, and that gives us approximately 10.5 centimeters would be the length of that guy right here. Now again, if you are more comfortable with degrees, can you make that conversion? Sure. Oh, here's my terrible picture. Looks like it's been rotated a little. But if this is 5 centimeters, and again, we're looking at this and it's 2 pi over 3, notice that you could say, okay, well, 2 pi over 3, if I wanted to convert that to degrees, all I would do is I would multiply that by the 180 over pi. Again, when you do that conversion, right, your pi's cancel. 2 times 180 is 360, and if we divide that by 3, so 2 times 180 divided by 3, we get 120 degrees. So we're looking at this, right? This is really like 120 degrees. So if you're more comfortable, again, just memorizing that first formula, you could do that and you could say, okay, well, arc length is just the whole circumference. So again, circumference 2 pi r, right, times the fraction in degrees. So notice using that different formula if we're in degrees. And then again, if we calculate that, we're getting essentially, right, that same thing. And I'm just going to calculate it and make sure that we do. And yep, looks great. We still get 10.5 centimeters. Okay. Arc length, again, is a piece of the circumference. So just make sure, especially when you're doing the applications in the next video, you always need the angle that's subtending that arc length out there, the arc length subtending the angle. Those need to be related there. If I wanted to find the other arc length, so the one I'm highlighting in green, I would need to figure out what this angle would be so that I could find that arc length. Okay. All right, over here on the right again, let's talk about sector area just really quickly in relation to radians. So let's kind of do this same one. Again, maybe I'll do a different one. So let's go here. Let's call this pi halves. And we can still call this 5 centimeters. That's great. So looking at this one, again, if I want to find sector area, and this time this guy is in radians, I'm going to box this over here so we remember, right? That's if it's in radians. Sector area, if it's in radians, is a little bit different as well. This one is actually going to be 1/2, whatever the angle is, and then you're going to times it by r squared. So again, this one's area, this one's related to that r squared. You are able to use your notes on your quizzes and stuff, so if it is in radians and you can't remember the formula, just make sure you have it written down correctly. And then the goal really is to practice using it this year. So here we go. If we want to find this sector area, we're going to do 1/2. We recognize this is in radians, so we do pi over 2, and then we multiply that by the radius squared. Okay, so again, we go ahead and multiply this, and it looks like on the top we're going to have 1 times pi times 25, or in other words 25 pi. 2 times 2 on the bottom gives us 4. So essentially there we have 25 times pi divided by 4. If we wanted to approximate that, that would be approximately 19.6 squared centimeters. Okay. And then again, you can do the same thing that we did with the arc length on the left. So I'm just going to work through kind of the same. If this is 5 centimeters, and let's say we were given pi halves and we just couldn't remember what that is in degrees, then we could make that conversion. So pi halves times 180 over pi. Again, if we simplify that, our pi's cancel. Oops. And we get 180 divided by 2, which is 90 degrees. So we can look up here, we know that that's just 90 degrees, or a fourth of the circle. So if I was more comfortable using that degree formula, then I could say, okay, well, pi r squared times, and then just the fraction of the circle, so 90 out of 360. Okay, and again, when we do that, we just calculate that out, multiplying pi times the 5 squared, and then we're going to multiply it by that fraction, and we will end up with, again, 19.6 square centimeters. So just practice with these two formulas, and then we're going to do some application.